Welcome to qnawire.
Hi, in this case we're going to have the titration of 25 milliliters of a zero point 0.1 molar solution of hydrofluoric acid that is going to be titrated with zero point 0.1 molar sodium hydroxide. So this is a strong acid with a strong base. We are going to have a one-to-one relationship in our neutralization reaction that is going to produce sodium chloride plus water. And we're asked to answer a set of questions based on this information. So first of all, what is the volume of sodium hydroxide added at the equivalence point? Remember that at the equivalence point, the amount of mole of HCl initial needs to be equal to the amount of mole of NaOH that we have added. We can transform this equation based on the definition of molarity. Recall that molarity is N divided by B. Thus, amount of mole would be the molarity times the volume. So, the amount of mole that I have at the beginning is going to be molarity of HCl times the volume of my solution. This needs to be equal to molarity of NaOH times the volume added. But guess what? Our molarities are the same. So the volume required of NaOH will be equal to the volume of the solution to reach equivalence. That is 25 milliliters. So now, for the next part, we're asked to get the pH after different additions. So what I'm going to do here is that we're going to fill out a table that is going to allow us to get our final result. Uh, First of all, we're going to have the volume added. We are going to have amount of mole of HCl that I have initially. Remember that the amount of mole of HCl is actually the amount of hydronium ion that I have in solution, or of H plus, depending on how do you want to look at it. This quantity is going to be kept constant. Next up, I'm going to write down the amount of mole of OH minus that I added into the solution. And this is going to be equal to the volume added times the concentration, the molarity of NaOH, that is zero point 0.1 molar. Then we're going to write down the amount of mole that we have at the end, and that is going to be either of H plus or OH minus that we're going to get in solution. With this, we can calculate the concentration. Again, this can be concentration of H plus or concentration of OH minus. And with this, we are going to calculate the pH at each of the points. Okay. So let's begin. We have different volumes of addition: 0, 5, 10, 15, 20, 30, 35, 40, and 50. The initial amount of HCl, it is going to be directly 25 times 10 to the minus 3 multiplied by 0 0.1 molar. This is going to be 2.5 times 10 to the minus 2 mole. Sorry, times 10 to the minus 3 mole. Okay? And that value is going to be kept constant at every step of our solution, minus 3 mole. And so on until the very end. Now, I'm going to add that extra column that is going to tell us what will be the final volume of our solution. Okay. That final volume at the very beginning is directly 25 milliliters. Then it becomes 30, 45, sorry, 40, 35, 35, 40, 45, 55, 60, 65, and finally 75 milliliters of total volume of the solution. That is going to help us to do the calculations of the concentrations. Next up, the amount of mole added of NaOH at the very beginning, it's going to be 0. Next up, it's going to be 5 milliliters. So 5 times 10 to the minus 3 times my concentration of NaOH. That concentration is 0.1. So over here I have added 5 times 10 to the minus 4. Then 1 times 10 to the minus 3. Next up, 1.5 times 10 to the minus 3. Over here, I'm going to get 2 times 10 to the minus 3. On 30, I'm going to have 3 times 10 to the minus 3. 35, 3.5 times 10 to the minus 3. At 40, 4 times 10 to the minus 3 mole. And at 50, 5 times 10 to the minus 3 mole. Okay? Now, I'm going to divide this into different sections. In the first one, the limiting reagent, it is going to be the OH minus. So, in all of this section, the limiting reagent is OH minus. After that, the limiting reagent is going to be H plus. So over here, the amount left, it is going to be the amount left of OH minus in the solution. So the final amount in this side, on the upper side of this table, the amount of mole left is going to be representing the amount of mole of H plus that I have in solution. So 2.5 times 10 to the minus 3. Next, 2.5 minus 5 times 10 to the minus 4. This is going to be 2 times 10 to the minus 3. 1.5 times 10 to the minus 3. Over here, 1 times 10 to the minus 3. And over here is 0.5 times 10 to the minus 3. And all of these guys are mole of H plus that I have left in solution. So the concentration, it is going to be then given by the division of the amount of mole for each of these guys by the final volume of solution. The results are the following: 0.1, 0.066, 0.044, 0.025, and 0.0111. And the only thing that we have left to do is take the pH. Recall that pH is minus logarithm of concentration of H2O plus. And for all of these guys, we can do the calculation directly. The pH at the first point is going to be equal to 1. Next up, we're going to have 1.18. Next, we're going to have 1.37. Next, 1.6. 1.95. Okay. Now, let's see what is going to happen after I have reached my equivalence point that I said that was at 25 milliliters. After that happens, the thing that is going to be left is moles of OH minus. And here I'm going to have 0.5 times 10 to the minus 3, 1 times 10 to the minus 3. Recall in this section, the limiting reagent is H0 plus or H plus. Next up, over here, I'm going to get 1.5 times 10 to the minus 3, and finally 2.5 times 10 to the minus 3. Now the concentrations, sorry about the ambulance, now the concentrations of this site are going to be concentrations of OH minus. Okay, and the concentration of OH minus is going to look exactly the same as doing the calculation. So I simply need to divide the amount of mole by the total volume at that point. So the results are going to look like this: 9.09 times 10 to the minus 3, 0.0166 periodic, 0.023, and 0.033. Now, this is concentration of OH minus. So for each of these cases, what I'm going to do is recall that pH is equal to 14 minus POH. And POH is equal to minus the logarithm of the concentration of OH minus. So simply, I need to go ahead and do that calculation with the concentrations that I found. For example, in the first case is 9.09 times 10 to the minus 3. I take the logarithm of that, take the minus sign, that is the POH, and when we add it to 14, I'm going to get 11.96. Same thing for the other ones, 12.22. Next, 0.023, 12.36, and finally 12.51. And this would be all for all of these different points. Finally, for part C, we're asked the pH at the equivalence point. Remember that at the equivalence point, what we're going to get is that all of the H3O plus coming from the HCl and all of the OH minus are going to react in order to produce water, thus generating a pH equal to 7, the pH of normal water. And to draw the overall curve, I'm going to just draw and sketch, but using the data points that I gave you, essentially you can get that the result is going to look something like this. And over here at the equivalence point, this is pH with respect to volume added. Here the value should be 7 at 25 milliliters. And you can complete the data points with the values of pH given in the table written here. And that would be all. Thank you very much.